Hey Math 1, you guys have a new video coming at you, section 2.9. We're still writing and solving equations, but this time we're using the distance formula. This is the science formula that relates distance, how far something travels, to how fast it's going, its rate, times the time at which it travels. Yeah, distance equals rate times time. So let's see if we can make sense of these three examples. The first one's all about trains. So we know that they're 560 miles apart and heading towards each other on parallel tracks, so that we're not going to have a train wreck here. Train A is traveling east at a rate of 35 miles per hour. Train B is traveling west at 45 miles per hour. And we know they're 560 miles apart. So we know that this distance right here is 560 miles. At what time will the two trains meet? So this is interesting. What I can do is come up with a formula for the distance that train A travels by basically taking its rate, which is given to us at 35, and then multiplying by the time in which it travels, which we don't know what that is, so we're going to give it the variable, let's just say t. So this expression represents the distance A travels. And here's the deal. It's going to be something like these trains will travel a certain distance, and then it's not going to travel the whole span of its 560 distance to meet up with B. It's only going to maybe travel to here, and this is only going to travel to here, and them together will make up the 560 miles. Sorry, that might have been kind of confusing to hear over video. Bottom line is, the distance that train A travels is 35t. The distance that train B travels is 45t. Together, distance 1 plus distance 2 gives us 560 miles. Okay, so hold on. My battery's dying and I don't want it to die in the middle of this video. So let's plug it in. Please don't die. Please don't die. Okay. Whew. I think we're good. So, as I was saying, the distance that train A travels plus the distance that train B travels must equal the 560 because they're going to meet somewhere in the middle, but the whole distance has been covered by at least one of the two trains. So all I got to do is say, hey, that's 35t. That's 45t. And then it becomes a pretty simple equation to solve. You just got to combine the t terms. And divide by 80. Remember your little shortcuts here, recognizing, hey, if there's a 0 at the end of the top and the bottom, they cancel. And then just having your math facts memorized. 56 divided by 8 is 7. So t equals 7. Now make sure with these word problems that we're given good units at the end so that we're absolutely clear. A when question will be a time question. Miles per hour should be 7 hours. So it'll take 7 hours when they meet up. Let's check out number 2. So let's see here. What do we got here? A moped begins traveling 18 miles per hour on a straight highway. At the same time and at the same starting point. So here's our starting point. Moped's going 18 miles per hour in this direction. A man is on a bicycle going this direction. And at what time, after how much time will they be 72 miles apart? This is the same exact thing. Instead of going towards each other and covering 72 miles, they're moving away from each other and covering 72 miles. So the moped's distance is still just going to be, hey, the moped traveled 18t. That's the distance, the rate of 18 miles per hour times t hours. Add that to the bicycle's travel time, or travel distance, which is 6t, because it's going 6 miles an hour. You add those together, and you get the full distance of 72 miles. And that's your equation. 18t plus 6t is equal to 72. So divide by 24. Remember, you can cut things in half to simplify them to make better mental calculations happen. So if you see t equals 72 over 24, start cutting them in half. I know half of 24 is 12, half of 72, 36. And then this is the point at which I recognize instantly that 36 over 12 is 3. 12, 24, 36. We're talking miles per hour, so that's 3 hours. So far, pretty easy equations to solve. You just have to have the presence of mind to be able to put it together. Now, number 3 is different. So a runner sprints past a gas station at 8.4 meters per second. After approximately 2 minutes, a motorcyclist finds the runner's cell phone lying on the ground and gets on the bike to return the runner's phone. Traveling at an average speed of 32 meters per second. That's pretty fast. How long did it take for the motorcycle to catch up to the runner? How much distance did the motorcycle cover in that time to make it happen? So we really we're being asked to answer 2 questions here. How much time did it take for the catch-up to occur? And then how much distance was covered in that time? So we have 2 distances, we have 2 distances here. So here's our gas station. Let's say the runner's in blue. Okay? The runner passes the gas station and continues running. At that point, let's say 2 minutes later has happened. This is the point at which the motorcyclist finds the phone and says, hey, I need to get that phone into the right person's possession. So the motorcyclist starts here. So here's the runner. Here's the motorcyclist. And the motorcyclist is going, but the runner is also moving as well. So it's sort of like, we're starting now, and the motorcyclist is catching up, and that's when they meet. So when you just look at this visually, the first thing that should come to mind is that the runner and the motorcyclist covered the exact same distance in this scenario. So the concept here is the distance that the runner ran and the distance that the motorcyclist cycled should equal each other because they both went the same distance. That's how catching up problems work. So what we're going to do is we're going to find an expression for the runner's distance, using rate times time, we're going to find an expression for the motorcyclist's distance, using rate times time in some way, and then we set them equal to each other. So to make things easiest on yourself, write this down. Always go from the perspective of the faster runner or the faster mover, in this case the cyclist. So we make this easy by just saying the motorcyclist is going 32 miles per hour times t. I guess it's got to be seconds because the rate's in terms of seconds, meters per second. So that's a good idea. We need to say that it's t equals seconds. All right, got it? Now, the distance that the runner runs is different. The runner's going 8.4 meters per second, but the runner has been traveling 2 minutes longer than the motorcyclist. So if I'm saying the motorcyclist's time traveling is t, I have to say that the runner's time is the motorcycle plus 2 minutes. Excuse me. Plus 2, but it's not 2 minutes. We have time in terms of seconds. 2 minutes is equal to 120 seconds. So I got to put 120 inside the parentheses and not plus 2. All right, can you guys see that? T plus 120. And as you can see, I use the red T here as the red T in here just to indicate that that's the same time value. It's just that the runner ran 120 seconds longer than the motorcyclist cycled. All right, this is tricky, okay? I'm not expecting everybody to get this right off the bat. Now we're going to solve this equation, and it's great because I'm incorporating the decimal multiplication and addition and subtraction, so yeah, I know you guys love me for the decimals, right? Let's go off to the side here and solve this. So 8.4 times t plus 120 equals 32 times t. So you take 8.4 times t, you get 8.4t. 8.4 times 120, let's go off to the side and multiply that out. 120 times 8.4. Remember, decimal multiplication just means ignore the decimal, multiply like normal. 4 times 0, 4 times 2, 4 times 1. Make sure you drop a 0 for the second row of calculations. 8 times 0, 8 times 2, 8 times 1, plus 1. Add the columns 0, 8, 0, 1, 10. 1 digit of decimal accuracy in the calculation means 1 digit of decimal movement. Okay, it's 1,008. All right, I need to get the t's on the same side, so I'm going to move the 8.4t to the right-hand side. And then here's another reminder that, hey, if I'm going to take 32 minus 8.4, I got to line up the decimals when I subtract. Didn't have to line up the decimals when I multiplied. Do have to line up the decimals when I add or subtract. All right, so this is 10 minus 4, 6. Borrow, 11. Got to borrow again. And yeah, it gives me 23.6. So 1,008 on the left, 23.6t on the right. Now we got to divide the decimal. So we talked decimal multiplication, decimal subtraction, decimal division. So the rule I kind of go by is let's eliminate the decimal inside the fraction, and then maybe dividing out will be a little bit easier. So if I multiply the top and bottom by 10, that's going to get rid of the decimal on the bottom, add a digit of 0 on the top. So it's 10,080 now on top, 236 on the bottom. I mean, hey, if you want to, you can try and reduce that by cutting the top in half and the bottom by half. It's a big number already. Maybe we should just go to the box right away and figure out what 10,080 divided by 236 is. But you know what? Half of 10,000 is 5,000. Half of 80 is 40. It's 5,040. I can cut this in half. Half of 200 is 100. Half of 36 is 18. I'm going to try to cut them in half again. Half of 5,000 is 2,500. Half of 40 is 20. Half of 100 is 50. Half of 18 is 9. All right. So 2,520 divided by 59, that might be the lowest that I'm going to make this. That's what t equals. What does that actually look like? Looks like we can fit 50, probably 4. Yeah, 59 goes in there 4 times. And then maybe 2 more. And then a lot of leftovers. Looks like 42 over 59. So t equals 42 and 42 over 59 seconds. Wow. So that's how much time it took the motorcyclist to catch up to the runner. And if you want to figure out what that is, I feel like my video is going a little bit longer than I had intended. I'll answer the second question in class. What's the distance that you covered? Spoiler alert, all you got to do is take that t-value, which is an atrocious t-value right now, which is kind of why I'm skipping ahead, and you would plug it into either the distance here or the distance here. So you're pretty much taking 32 times 42 and 42 59ths to get that. All right, thanks for enduring to the end of the video. I really appreciate you guys watching this. So, yeah, thank you.